Next in our series of properties of exponents is the power of a power. So the objective here is to understand raising a power to a power. So let's explore what this means. Let's take the number 2 to the 4th raised to the 3rd. So what does that mean? We can use the order of operations to evaluate this expression. So let's first evaluate the expression inside the parentheses. So inside the parentheses, I have a base of 2 and an exponent of 4. This means that my base is multiplied by itself by the number of times seen in the exponent. So this means that I would have 2 times 2 times 2 times 2. Because that's 2 times itself 4 times. And that would still be raised to the power of 3. So I can now continue to look inside my parentheses. So 2 times 2 times 2 times 2. When I evaluate that, that gives me 16 to the 3rd. Now if I expand that, I would have 16 times 16 times 16. With a little bit of math, I would figure out that this is 4,096. But we can also evaluate the expression by using 2 as a factor 12 times. So let's explore this. Let's draw a line in between and look at this another way. So if I still have 2 to the 4th raised to the 3rd, I can still look at this as 2 times 2 times 2 times 2 raised to the 3rd. But instead of going to and multiplying all those 2's together, now let's take a look at this as groups of 4 factors of 2. So I would have 2 times 2 times 2 times 2, all multiplied by another set of 2 times 2 times 2 times 2, multiplied by another set of 2 times 2 times 2 times 2, to give me all of this, gives me 3 groups of 4 factors. Which would give me 2 raised to the 4 times 3. So 3 times 4 would give me 12 factors of 2, which, when I figure that out, equals 4,096. Let's use the same method to evaluate n to the 2nd raised to the 5th. So if I look inside my parentheses first, I would have n times n raised to the 5th. Now, let's expand that out. So I would have n times n multiplied by itself 5 times. 3, 4, 5. So here I have 5 groups of 2 factors, which will equal n raised to the 2 times 5, to give me my 10 factors of n. So I get n equals 10. So now we can write our definition of a power to a power. So when we raise a power to a power, we keep the base and multiply the exponents. So the rule would look like this. So let's say I have a base of a raised to the m power. Then outside of that, I'm going to raise that to a power of n. I then keep my base and I multiply my exponents together. And you don't have to write the multiplication sign. Oops. You can put them right next to each other. So you have m times n. When they're written right next to each other, we know that they're being multiplied. We don't have to write the multiplication sign to indicate that.